Let's start with these two functions. Told you. F of x equals x plus 5. If I graph it, what shape is that? A line. And what's the domain of a line? All reals. And if I graph g of x, what shape does that make? A parabola. And what's the domain of a parabola? Okay. Today we're focusing on two major things. One is operations of functions, and one is composition of functions. Okay, so let's deal with operations first. Okay, now, do I mean like getting your appendix out? That kind of operate? You don't want to do those operations in this class? No, I'm sorry. No, we can't. No. First of all, that would mean me giving you knives, and that is not going to happen. Okay. What do I mean if we're talking about operations in a math class? What operations are we talking about, though? When we talk about order of operations, what are we talking about? Addition, subtraction, multiplication, division. So let's start with f of x plus g of x. Now, just for the record, well, let me do the problem first, and then I'll go back for the record. Okay? What does it want us to do? Add. So f of x is x plus 5, and g of x is x squared minus x minus 6. So really, all I'm doing is combining like terms, aren't I? So I get x squared, x minus x. Well, that's 0, isn't it? And then I got 5 and negative 6. Negative 1. Okay, done. What's my new domain of my new function? Yeah, how do you know it's all reals? It's a parabola, right? Parabolas. It's a functional parabola, which means my domain is all reals, or negative infinity to positive infinity, right? We're working on interval notation today, so we're going to write our domain like this. Okay? Good so far? Oh, remember how I said for the record in the beginning, and then I said let me do the problem, and then I'll come back to that? There's a different way this can be written. It can be written f plus g of x. That make sense? F plus g of x, but those two things mean the same thing. Does that make sense? Why do we have two ways to write one thing? Because two different people came up with it and they didn't talk, and no, I'm just teasing. I don't really know. It's just two different ways to write the same thing. Okay? Now we have f of x minus g of x. What's it asking us to do? Subtract. F of x is x plus 5 minus g of x, which is x squared minus x minus 6. What do I have to include this time? Yep. Why was it not important the first time? Does it matter what order you add stuff in? No. Does it matter what order you subtract stuff in? Yes. Okay? So what do I have to do with this negative sign to begin with? I do have to distribute. So x plus 5 minus x squared plus x plus 6. Now what do I do? Combine like terms. What do I end up with? Negative x squared plus 2x plus 11. What's the domain of that function? How do you know it's all real? It's a parabola? Yeah, but it opens down, doesn't it? Oh, domain is the x value, so it doesn't matter, right? Doesn't matter if it opens up like this first one because it's got a positive a value, or if it opens down like the second one that's got a negative a value, does it? Okay? Now what? We just did add, oh wait, let's write this also. How can this be written a different way? F minus g of x, right? So we did adding and subtracting. What's next? So f of x times g of x. What do we have to add from the beginning this time? Parentheses, right? X plus 5, x squared minus x minus 6. Now, why didn't we add parentheses here? Could we have? Absolutely. But it would give us an extra step to take everything out of the parentheses and then add combined like terms, right? Why didn't I put a parenthesis on this one? It was the first one. I could have, right? I could have put a parenthesis, but there's not a negative in front, so it wasn't that important. Okay? Why do I have to have parentheses on this one? What if there wasn't any parentheses? What would it imply? Yeah, that only the 5 was multiplying, right? But it's the whole thing. It's all of f times all of g, right? So how do I solve this problem? Distribute. Excellent. X times x squared, x cubed, x times negative x minus x squared, good. X times negative 6 minus 6x. 5 times x squared, 5 times negative x, and then 5 times negative 6. And now, combine like terms. Excellent. X cubed. Good. 4x squared. Everybody okay why it's 4x squared? Yeah, a minus 1 and a positive 5, that's positive 4. And then I've got negative 6x and negative 5x. Negative 11x, and then minus 30. What's the domain? Don't tell me it's a parabola. What is it? Oh, it's a cubic. Didn't we just talk about those? Yeah, what's the domain of a cubic? All real. Isn't that nice? Can this be rewritten some other way? F g of x. Yeah, there could be like a times in between, like an x or a times, or it could just be f g of x. Okay? Questions? Feeling comfortable? Confident? Excellent. What's left? So f of x divided by g of x. This is my favorite and not my favorite. Can I explain? Okay, f of x in this problem is x plus 5. In this problem, g of x is x squared minus x minus 6. Done. That's why it's my favorite. This is why it's not my favorite. I have to decide what my domain is, right? It's a fraction, right? What is the denominator of a fraction not allowed to equal? God bless you. What's the denominator of a fraction not allowed to equal? 0, right? It's not allowed to equal 0. So what I have to do is figure out where it is 0, and then that cannot be part of my domain, okay? So I actually have to step away and say x squared minus x minus 6 equals 0. I have to take the denominator and actually set it equal to 0. How am I going to solve this? Oh, factoring, right? Factoring, okay. What multiplies to be negative 6 and adds to be negative 1? God bless you. Negative 3 and positive 2, excellent. So what's x minus 3 equals 0, and then x plus 2 equals 0? our zero product property, remember that? So what does x equal then? 3 and -2. So what I just found by setting the denominator equal to 0 is what my domain is not allowed to be. My domain can be anything but these two numbers. So do you remember how to write that as a domain? No? Can I help? Okay, so I'm starting over here at -infinity. Oh, ignore that. I don't know why I drew a second one already. Sorry, so fast. Starting off at -infinity, and I'm coming across my number line. And what do I get to first? -2. And I have to stop. And then I have to start on the other side of -2 and go to where? 3. And then I have to stop on the and then start again on the other side of 3 and then go to infinity. Okay? Just as a reminder, when we're talking about interval notation, we're using parentheses for numbers that are not included, and our U means union, right? It means and. So it goes from -infinity to -2 and stops and doesn't include -2, and then it starts on the other side of -2 and goes all the way to 3, but then it stops, doesn't get to 3, but it starts on the other side of 3 and goes all the way to infinity. Do you remember that? We talked about it already at the beginning of the year, but it's been a while, so I wanted to remind you. You good? So do you see why it's my favorite and not my favorite? Yeah? Okay. But did anything that we just do, was anything we just did hard? No, we've done it all before, now we're just like putting it together. Okay? That's operations of functions. Do you need any more examples of adding, subtracting, multiplying, or dividing? Feel comfortable and confident in these? Okay. Then let's talk about composition of functions. Okay. Now, notice this is the same f of x and g of x is on the front. Okay. I could have used different ones. I just didn't. Okay. Composition of functions looks like this. Is that a multiplication symbol? No, because it's not filled in, right? It means f of g of x. Can I take a quick commercial break? If I tell you f of x is x plus 5, and I ask for f of 4, sorry. If I ask for f of 4, what am I asking you to do? Anywhere there's an x, I put in a 4, right? So 4 plus 5, what is f of 4? 9. So because I wrote f of 4, that means anywhere there's an x, I put in a 4. So what do you think I want you to do if I ask for f of g of x? Another way that this can be written is f of g of x. What do you think I want you to do in f? Put in g of x. Okay, so I start writing f, but anytime I get to an x, I write a g of x. Just like we did on this commercial break over here, anywhere there's an x, I wrote g of x, and then finish the problem, right? The difference this time is up here was 4. I know 4. 4 plus 5 is 9. Okay, great. Do I know g of x? Oh, yes, I do right here, right? So can't I then say x squared minus x minus 6 plus 5? Isn't that g of x? And what do I have left to do? Combine like terms, right? Simplify. X squared minus x minus 1. Done. But see, I'm also going to ask for g of f of x, which could also look like g of f of x. So this time, which one do I want you to start writing? G, and anytime I get to an x, what do I want you to write? F of x. So f of x squared minus f of x minus 6. Do I know f of x? What is it? X plus 5? So x plus 5 squared minus x plus 5 minus 6. What do I mean when I say x plus 5 squared? Oh, x plus 5. So you don't want me to just square the x and square the 5? No, excellent. I'm proud of you guys. So it means x plus 5 times x plus 5, right? Now I still have the rest of this stuff, so I'm just going to bring it down for now, because I'm just trying to give myself a heads up about what's going on, right? I'm rewriting stuff to make it easier. What do I need to do with these two parentheses right here? So x times x times 5, 5 times